Hello, geometry students. Today we're going to be going over the Unit 1 workbook. So we're going to be going through everything in the workbook in Unit 1, except for the activities in this video. The activities are recorded in another video, and the review is also recorded in another video. So if you're looking for the activities or the review, those videos should be up in the Google Classroom, or they will be up shortly. This video is just covering everything else in the workbook. So the main bulk of the instruction, going to go over all that with you. And everything I write on here, you should write in your book. Okay, so that's kind of the key, is everything I write, you write. All right, and show your work. And that goes for basically all these videos. So let me share my screen with you, and we'll take a look at the workbook here. So your workbook should look like this, and we could just open up your page, and we'll go down to page 2. So we're going to talk about what's on this page and talk about everything else. So there are 4 different types of transformations. Okay, 4 different types of transformations. So one is a translation. So notice for a translation, they translated this R to this blue one, but basically notice it's just moved, right? It's just shifted over. That's a translation. It's still facing the same way, still the same orientation. It's just in a different place. The next type is rotation. So that's rotating the object. Reflection. So reflect the object across a line of reflection. And lastly, dilation. So dilation, notice the size of the image is larger than what you had before, right? So this one's a little bit different, dilation, because you're changing the size. So the new one is not the same size as the original. But for these first 3, translation, rotation, reflection, the original is the same as the image. Okay. Now, the original one is called the pre-image. So we would say the pre-image is the same as the image in a translation. Also, the pre-image is the same as the image in rotation and also in reflection. But the image and pre-image, the image and the pre-image are not the same size in a dilation. That's kind of key. So let's talk a little bit about, I can explain all this in a bit. So let's go down and we'll just start explaining some of the problems here. Now, when it comes to if the image and pre-image are the same size, so the translation, rotation, reflection, if the image and pre-image are what we call congruent, and you're going to hear that word a lot in this course, is congruent, meaning same exact size, same exact shape. So in a translation, the pre-image and image are congruent, we would say. So for translation, rotation, reflection, the image and pre-image are all congruent. Well, then these 3 have a special name. They have a special category. They're what we call isometries. Okay, an isometry. And basically, an isometry keeps the same shape, the same size. And they also are called rigid motion. So all 3 of these are considered rigid motion. So because they don't change size, they don't stretch, they don't change the shape. So we call these rigid motions. So translation, rotation, reflection, they're all rigid motions. Okay. So let's go down to page 6 and start working on this. So for number 1, it says, does the transformation below appear to be rigid motion? So here's the starting one, the pre-image, and then it went to this image. So if we start here and we end up there, did we keep the same size, same shape? Well, no. So is this rigid motion? Remember, rigid motion means it's going to keep the same size, same shape. So this would be no. This is not rigid motion. Okay? No. Because the image is larger than the pre-image. So remember, for rigid motion, the image and pre-image should be congruent. Is larger than the pre-image. Okay. In other words, the image and pre-image are not congruent, so this is not rigid motion. Okay. So in this one's case, the pre-image is here, and then the image is right here. In this case, these two triangles are the same shape and they are the same size. They're just slightly in different orientations. So in this case, these two triangles are congruent. So this would be rigid motion. Okay, so I want you to say yes and then comma, because the image and pre-image are congruent. So go ahead and finish writing that there. And once you're done with that, pause the video and do that, and let's move on. Now let's talk about some of the notation we're going to see. So do you see where this says, and it has an example here, that what does T, and then you kind of see like as a subscript here, you have these like little less than, greater than symbols, and then 2, 3, ABC equals A prime, B prime, C prime. What does this mean? So this means that the pre-image, which is triangle ABC, is translated. So the capital T tells you translation. Okay, so it's translated. And then these two numbers, the 2 and the 3, they tell you how you're moving the object. So in this case, 2, 3 means we're going to move 2 to the right and 3 up. Okay, 2 to the right and 3 up. So when you see a capital T and then the subscript, whatever these two numbers are, that tells you how the object is moving. So if it's whatever number they put first, let's say it's a 5, this tells you you're moving 5 along the x-axis. So the first number tells you how you're moving horizontally along the x. And then the second number, let's say it's a -1 or something, this tells you how you're moving across the y. Okay, so that's kind of the key here. When you see this translation, these numbers down here tell you how you're going to translate the object. So in this case, you would translate the object 5 to the right and 1 down. Okay, so the first number tells you left or right and how much. The second number tells you up or down and how much. Now, what does this one mean? So we have T, and then the subscript, we have -2, -2. So that means we're pre-image. So we'll kind of just copy what it says here, but we're going to change the numbers and stuff. So pre-image ABC. The pre-image is always listed first here in these transformations, is translated so this time it's -2, -2. So the first one tells you how you're going to move along the x. The second number tells you how you're going to move along the y. So we're going to translate, in this case, 2 to the left and so the second one is also a -2, but that would be 2 down. To make image A prime, B prime, C prime. So generally the image usually gets these like apostrophes, but we call those primes. So you'd read that as A prime, B prime, C prime. So the image usually gets those primes like that. All right, let's try the next one, number 4. Notice for this one, it just says X and Y. Let's go ahead and put some numbers there. And we can just do that. So let's pretend it said, instead of X and Y, let's do 4, comma, and 10. Okay, and I want you to finish this one just like how we did number 3. Okay, so the preimage ABC is translated, and then tell me how it's translated to make image A prime, B prime, C prime. Okay, now number 5. What does QRST, and then it has an arrow, Q prime, R prime, S prime, T prime? Well, we know the pre-image is the first one listed, and the one with the primes is the image, right? So we would say pre-image QRST. Now it doesn't say it's a translation, right? We don't see the capital T like over here. So we don't know if it's a translation or a rotation or a reflection. But we know that the pre-image is QRST. And we'll just say it's transformed. So we don't know what type of transformation, but we'll just say it's transformed to create image Q prime, R prime, S prime, T prime. Okay, now let's move along. On page 8, let's take a look at these shapes here. In the diagram below, ABC is transformed to make A prime, B prime, C prime. List all the corresponding sides. So when we write the corresponding sides, so we're looking at the sides of the triangle. So the sides are what connect the two vertices or the two corners of the triangle. Okay, so that's considered a side. So we want the corresponding sides. So in our case, AB from the pre-image, right? This is the pre-image. AB is congruent to A prime, B prime. Okay. So let's talk a little bit about the notation here. Notice I put a little bar on top. So whenever you see a line segment, meaning like a connection of 2 points, so this connection here, we would label that as A, B, and we put a little bar on top, okay? Same thing with A prime, B prime, or any line segment that connects 2 points, we would put a little bar on top like that. Now this symbol in the middle is congruence. So we would read this as line segment AB is congruent to line segment A prime, B prime. And this congruent symbol basically means they are the same measure. So AB is the same measure as A prime, B prime. Okay? So whenever you see this symbol, it means congruent. You're going to see it a lot. You're going to hear that word a lot. So you got to know what that means. It means that those two things have the same measure. Okay? So let's list the other corresponding sides of these triangles. So we already talked about AB, which is here. What about BC? Okay, so that's BC. And what would be its corresponding side? So that would be B prime, C prime. Okay. Unsurprisingly, these are congruent to each other. Lastly, the last side, AC, which will be congruent to segment A prime, C prime. Okay. Now number 7, in the diagram below, DEFG is transformed to D prime, E prime, F prime, G prime. Lists all the corresponding angles. Okay. So now let's talk a little bit about some more notation. So the angle notation kind of looks like a less than, like that. So here we would say like angle D will be congruent to angle D prime. Okay, these are corresponding angles. So this angle corresponds with this angle here. Okay. Also, angle E will be congruent to angle E prime. Okay. Angle F will be congruent to angle F prime. Lastly, angle G will be congruent to angle G prime. Okay. See if you can do number 8 on your own. So this one's asking for the corresponding angles also. So just like number 7. Once you're done with that, let's go on to page 9. So for page 9, it says use the translation rule T and then 2, 2, triangle ABC to graph the translation of pre-image triangle ABC. So basically we want to take this triangle that's in this picture, ABC, and we want to translate it according to this rule. So we want to translate it 2, 2. So that's going to be 2 to the right and then 2 up. So we're going to move 2 to the right and 2 up. So we're going to take each of the coordinate points from the original triangle and we're going to create the image. So from A, notice where A is, we're going to move 2 to the right and 2 up. So after moving 2 to the right and 2 up, A prime will be right here. So remember, for the image, for the new one, you're going to get the primes, right? So for B, same thing. We're going to move 2 to the right and 2 up. So each of the points get translated according to that rule, 2 to the right, 2 up. Same with C, 2 to the right, 2 up. And we'll label it C prime. Then we connect the 3 points to create our image. Notice that the pre-image and the image, they should be congruent, right? They should be exactly the same. I would suggest using a straight edge, like a ruler, to help you draw it as nicely as possible. Hopefully it's nicer than mine. Okay, but that's how you know you did it correctly, is that the image and pre-image should be congruent, right? Because translations is just shifting it. Now let's try number 10. I'll get you started on it, but I want you to finish it. So use the translation rule T, and then in subscript, -5, 3 for triangle ABC. Okay, so here's triangle ABC, and we want to move 5, since it's negative, that'll be 5 to the left. And then the 3, up 3. So let me show you where A is going to end up. So we're going to move 5 to the left, 1, 2, 3, 4, 5, and 3 up, 1, 2, 3. Okay. So this is where A prime will be. Okay. See if you can find where B prime and C prime will be, and then create the image. Let's go ahead and pause the video and do that. Once you're done with that, let's move on to the next one. So here, they give us the image and the pre-image, and we need to figure out what's the translation that maps the pre-image onto the image. So triangle DEF to triangle D prime, E prime, F prime. So what we would say, well, it's going to be a translation, right? It's shifted, but I need to figure out how it's translated. So we're going to put some numbers down here. Now, I can start by looking at D and figuring out how to get to D prime. So first I would look horizontally, so meaning left and right. So how do I go from this D to D prime? How much do I move? Well, that would be moving 2 to the right. So moving 2 to the right, we put a positive 2 here. Okay. If it was to the left, we would put negative 2. But since we're moving to the right, positive 2. And then 1, 2, 3, 4 down. So negative 4, since we're moving down 4. From E to E prime should be the same. From F to F prime should be the same. You can check. So from E to E prime, 2 to the right, and 1, 2, 3, 4 down. Okay. And then we would put triangle DEF, and then equals triangle D prime, E prime, F prime. All right, and that's it. So this tells you this is the translation rule that takes the original DEF, the preimage, and maps it onto the image triangle D prime, E prime, F prime. Now see if you can do the same for question 12 here on page 10. I'll help you out a little bit. Let's say I wanted to go, we start with the preimage right here, let's say at A, and let's go to A prime. So how much would that be shifted? 1, 2, 3, 4, 5 to the right, and then 1, 2, 3, 4, 5 up. So see if you can write the translation rule that maps this preimage onto this image. Okay, go and pause the video and do that. And let's move on. We're going to translate some points here now. So for number 13, it says a point beginning at 0, negative 2. So the first thing I'm going to do is plot that point, 0, negative 2. Well, that's right here, 0, negative 2. Notice this is the x coordinate and this is the y coordinate. So you have nowhere left and right, and then you go down 2, so that's where our point is. Okay. Maybe that was the, I want to draw it more circular, more small too. Okay, like that. Then it undergoes the following composition of translations. Write an ordered pair for the point final position. So notice it has a first translation is 3, 5. So that means from the point that from our original point, we're going to translate 3, 5. So that's going to be 3 to the right and then 5 up. Again, the first number tells you left or right. Second number tells you up or down. So we're going to move 3 to the right, 5 up. 1, 2, 3 to the right. 1, 2, 3, 4, 5 up. So now it's right here. Then we want to translate 0, negative 1. So 0 left and right, and then negative 1 down. So that's down 1. So go down 1 from now this point. So down 1 here. Okay. So this is our final answer right here, this point. Go ahead and circle it. So this is our final answer here. So what are the coordinates for this point? Well, this would be at 1, 2, 3, 2. So our new point is at 3, 2. That's the new coordinate point after we've taken this point and we translate it according to these two. For this one, let's go ahead and work on it. So the point we're beginning at is negative 3, 1. So negative 3 on the x and then 1 on the y. Okay. See if you can finish the rest of this. So you're going to translate 8 to the right, 4 down. Then after that, 2 to the left, 2 down, and then write the final coordinate point. So see if you can do that on your own. Next, we're going to talk about reflections. So when we reflect across a line, and I'm going to show you basically how to do it with these two examples here. So when you reflect across a line, the first thing you need to know is where's your starting point. So in our case, we're starting with this point A. And it says A is at -4, 3. And we can see that, -4, 3. So here's where A is. That's our pre-image. And we're going to, the reflection, the way we write reflections is with a capital R. And then in the sub, you put in the subscript, you put what the line of reflection is. So in our case, that's R for reflection, capital R. And then underneath here, it says y-axis. So that means we're going to reflect point A across the y-axis. And you can see they kind of set it up already, right? They put point A where it belongs, and they put a dotted line for the y-axis. So that shows us our line of reflection is the y-axis. Now, when you reflect, what's important is that the distance to the reflection line matches the distance away from the reflection line. So notice how far our pre-image is from the reflection line. 1, 2, 3, 4. So that distance is 4. So that means I want to go 4 in the opposite direction. 1, 2, 3, 4. This gives us our image. And there you go. So now the coordinate point for that, for A prime, so A prime will be at 4, 3. 4, 3. And there you go, all done. So notice the distance to the reflection line matches the distance away from the reflection line. Now let's try this one. So point A is at 5, 4, and they've already plotted that point for us. Graph and write the coordinates of, and this time it says R, reflection, and then it says x equals 1 on A. So we're going to reflect A across the line x equals 1. So one thing to keep in mind is when it says x equals 1 or x equals anything, that'll be a vertical line. So x equals 1 in this example is a vertical line at 1. See, it's 1 on the x-axis. It'll be a vertical line there. Also, if it said y equals something, that would be a horizontal line. That'll come up later. So let's reflect this point, point A, across this dotted line. X equals 1. So how far is A, our pre-image, to the reflection line? 1, 2, 3, 4. Okay, 4 away again, same as over here. Now from here, from the reflection line, we want to go 4 away in the opposite direction. 1, 2, 3, 4. So here's where A prime lives. So A prime is right there. So in our case, A prime is at, I guess I'll put a colon here. A prime is at -1, 2, 3, right? 3 to the left, and then 4 up. And there you go. Let's talk about reflecting shapes now. So give the following triangle. Triangle ABC, graph, and then we want to reflect triangle ABC across x equals 2. So the first thing we want to do is draw that line of reflection, x equals 2. So since that's x equals, it's going to be a vertical line, and we want to go where x equals 2. So that's right here. So that's going to be a vertical line right there. So I'm going to draw this dotted line. I suggest you do the same on your paper. And we want to reflect our triangle across this line. Let's actually start with point C, okay? So C is right here at 3, -1, and we want to reflect across this line. So C How far is C from the reflection line? Well, it's 1 away, right? So we want to go 1 away in the opposite direction over here. So this is where C prime lives. Notice they're both 1 away from that reflection line, C and C prime. Now let's do B and find B prime. So let's see, how far away is B from our reflection line? 1, 2, 3, 4. So I want to go 4 away in the opposite direction. 1, 2, 3, 4. It's going to be off the chart a little bit, but that's okay. So B prime is going to live over here. You want to imagine this grid goes on forever. Okay. Don't worry about if it goes off the picture a little bit. A is on the reflection line, isn't it? So A is on the reflection line. So when you reflect it, it just stays put. So how far is A from the reflection line? Well, it's 0 away, right? It's on the reflection line. So when you reflect it, it stays there. So A and A prime are actually the same point, right? They have the same coordinates. Then we connect our A prime, B prime, and C prime to create the image. Just like that. You should notice that the original triangle, the pre-image, and the image, they're actually congruent to each other, right? They're the same size, same shape. They're just reflected. So reflections, they should conserve the same size, same shape. So the image and pre-image during a reflection should be congruent. Okay, and that's it. So we graphed now the image. Now let's try number 4 here. So in this case, we're going to reflect across y equals -1. So y equals is going to be a horizontal line, and we do it at -1. So that's going to be across here. Okay. Then you would reflect each point across this reflection line. So A is 1 away from that reflection line, right? So going from here, A, to here, that's 1 away. So A prime will be 1 away going in the opposite direction. So A prime will be right here. A prime. B is 3 away from the reflection line. 1, 2, 3. So we want to go 3 away in the opposite direction. 1, 2, 3. B prime would be right here. C prime is also 3 away from the reflection line. So you go 3 away in the opposite direction. Connect the 3 points to create the image. And now you have triangle A prime, B prime, C prime. And you might notice that, yes, these two triangles are congruent to each other. Now, let's go on to page 16. So here's an example they give us. It says, which reflection rule describes figure 6? And so they wrote it like this. So which reflection rule describes figure 6? So you can see where figure 6 is right here. And you might notice that all of these figures kind of look the same, right? They're just kind of going all different ways. But if you notice that figure 6, if you reflect across line P, you would end up at figure 3. Okay, so which rule describes figure 6? Well, if you take figure 3 and you reflect across line P, you'll get figure 6. So that's what this is saying. It's saying start off with figure 3 as the pre-image, and then you reflect across line P, and you'll get figure 6. Okay, I hope that kind of makes sense. So when it says, which reflection rule describes figure 2, I'm looking at question 5 here. So figure 2 is right here. So which of these other shapes would be a reflection to get figure 2? Well, hopefully you can see that it would be figure 1. So we would write figure 1. Figure 1 equals, and then reflecting across. So it's reflecting across this line again, right? That's line P. So take figure 1, reflect across line P, and you get figure 2. Reflect across line P, and then you get figure 2. Okay, so if we take figure 2, we reflect across line P, you get figure 1, right? It goes both ways. Reflect figure 1 across line P, you get figure 2. Reflect figure 2 across line P, you get figure 1. Which reflection rule describes figure 4? So you might be tempted to say, oh, 5, right? If you reflect across line P. But actually, they wouldn't be going the right way. You see how this one has 4 has its short side here, and then 5 has its long side here. So if you reflected across that, that wouldn't really work to get that. It's actually across, we want to reflect figure 4 across line N. And that'll give us figure 8. You see that? So figure 4 and 8 are a reflection across line N. Notice the same distance from N, right? So if you go from here to N. So if I connect corresponding points, you see? Okay, so we would say figure 8. This time we're not reflecting across line P, we'd be reflecting across line N. Figure 4. Number 7, which reflection rule describes figure 8? Okay, so for number 7, I want you to try this one on your own. It's basically the same as what we did for number 6, okay? Notice 8 and 4 are a reflection across line N, so you should be able to just rewrite this, but flipped around a little bit. It should be like figure 4 equals the reflection across line N, figure 8. Which reflection rule describes figure 5? Okay, I'll give you a hint. You're going to be reflecting across line N again. Okay, let's see if you can figure out the rest of that for number 8. For this concept bite here on page 17, I did that on a separate video, so you can watch that video after this one. Okay, now we're going to talk about rotations. Okay, now it gives you these rules here about rotations. Now notice that the main rotation angles we're going to use are 90, 180, 270, and 360. So each of those are like multiples of 90, right? So 90 times 1, 90 times 2 is 180, 90 times 3 is 270, and 90 times 4 is 360. So they're all kind of rotations of 90 more, let's say. And notice for rotations, it's not a capital R, it's a lowercase r, right? So for capital R, if you see capital R, that's for reflections, like we just covered. But if you see a lowercase r like this, that's for rotations. Okay? And then it has these rules that you can follow about, notice if you're rotating 90 degrees and you have the coordinates x and y, then the x and y, they flip positions, and then whichever one was the original y would get a negative. And the example they show here is what 3, 2, when you rotate it 90, it becomes negative 2, 3, right? Notice the numbers switch, and what was the original y got a negative. Right? When you're rotating 180, both the x and y just get negatives on them, right? So 3, 2 becomes negative 3, negative 2. Now you can memorize these rules if you want, and this easily helps you to find the correct rotations. And there's a rule for 270. For 360, with 360, that means you're going all the way around. So the coordinates don't change at all. So when you go all the way around, rotate 360, whatever your original coordinates were, that's what your new coordinates are because they're in the same position. Going around 360, you end up in the same position. Okay. Let's go on. I'm going to show you some tricks to do with some tracing paper, and I'll show you how to easily find rotations. Now, the first thing I want you to do is on page 21, I want you to ignore this example because this example does not belong here, actually. Okay, I don't know why this example is here, but ignore it. Okay, but we're going to talk about this example here. So it says, does the image below approximately represent a rotation of 270 degrees for triangle ABC? So we're starting with triangle ABC, and it's asking, is the rotation from triangle ABC to triangle A prime, B prime, C prime, is that 270 degrees? So I'm gonna show you over here, and you can see I printed out this page here, and this here. Okay. And I have some tracing paper. Okay, so you can put the tracing paper over it, and you should be able to see the original paper underneath. And what I like to do is, I like to set up my tracing paper so that it's kind of in line with the paper underneath. Right. So the top of my tracing paper is parallel to the top of this. The side is parallel to the side here. The bottom across the bottom. The right across the right. So I don't want to do it like where it's all like this. I want to do it where my tracing paper kind of lines up with the corners. See? Okay. Now the way you use the tracing paper is every time you rotate the tracing paper 90 degrees, it'll be where the other corner lines up. So for example, if I start with this is my top, let's say. I'll put an arrow here for the top so you remember where it's at. And if I rotate 90, I would rotate, and now it's pointing to the left. Okay, now this corner lines up. See that? And then if I rotate another 90, so rotate 180 in total, now it's pointing down. Originally it was pointing up, but now it's pointing down. So that's a rotation of 180. 270 rotation, now it's pointing to the right. And then 360 gets us back to where we started. So 360, the original is back where it started. So the image and pre-image are in the same position. Okay. So one thing to, if you need tracing paper, you can ask me if you're at the Rancho Center, or you could ask, whoever is at your center that might have some tracing paper. They should have some on hand. If not, they can always order some. So the way you use the tracing paper for rotations is the first thing I want to do is I will rotate, or I will put a point at the point of rotation. So there's a point of rotation. I'll go ahead and darken that. Then I want to trace the original, the pre-image. Okay, so I want to trace that triangle, the pre-image. It's triangle A, B, C. And then I put my pencil, the tip of my pencil, at the center of rotation. Then I want to rotate my paper, and I want to see how many degrees rotation does it take to get from this triangle to this triangle. So first I'm going to rotate. Okay, so I've rotated 90 so far, and you can see it. My two triangles don't line up yet. Here's 180 rotation. Okay, and now it's here. So now my paper, I rotated 3 times, so that was 270. So it asks, does the image below approximately represent a rotation 270 degrees? We would say yes. 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 Okay. Now let's try the next one. So you might want to erase what you put on your tracing paper. you could use the tracing paper probably 3 or 4 times until it's too smudged up, but, try to conserve the paper. So question 1 says, does the image below approximately represent a rotation of 180 degrees? So again, you put the tracing paper over it, and I'm lining up where this side of my tracing paper lines up with this side of the actual paper, right? So then I put a point at the center of rotation. I trace the pre-image, triangle ABC, put my pencil at the center of rotation, and I see how much I rotate to get to the image. Okay, well, I only rotated my paper once, right? So if this is like, put an arrow at the top, I only rotate it once, now it's pointing to the left. Okay, so I only rotated one iteration, so that was only a 90-degree rotation. So does the image below approximately represent a rotation 180? We would say no. It's a rotation of 90 degrees. Okay. See if you can do this one on your own. So notice the image and pre-image are in the same spot. So does this image below approximately represent a rotation of 360? Well, is it in the same spot? Think about that, okay? Now let's do number 3 here. Okay, here they have a coordinate grid. So sometimes what I like to do with the coordinate grid, and this helps me out a bit, is I'll trace the X and Y axis also. So maybe I'll do that. So I'm going to trace the Y axis here and the X axis here. Okay. And then again, I trace the original, the pre-image, A, B, C. Okay. Now I'll put my pencil at the 0, 0. So that's what we're rotating around. Now every time I rotate, see how I'm rotating? Every time these axes line up again, that's 90 degrees rotation. So if I rotate, okay, notice how the axes line up again. So that was a 90-degree rotation. So if we were going to rotate 90, the image would end up over here. Okay, I rotated another 90, so that's 180 in total. Notice now it lines up with the image. So this was a rotation of 180, therefore, right? So then it says write a rotation that maps ABC onto A prime, B prime, C prime. So we would write R, lowercase r, for rotation. And how many degrees did we rotate? 180 degrees around. And then if we're rotating around 0, 0, a lot of times we just put the letter O because O represents the origin, which is 0, 0. And then we would say triangle ABC, and then equals triangle A prime, B prime, C prime. Just like that. Okay. Hopefully you can see that. Maybe here's focus. Okay. Anyway. That was page 21. Let's go on to page 22 here, and we'll talk more about rotations here. So for question 4, it says, write what happens to each coordinate for the following rotation transformation. Okay, so we want to write where the coordinates go, basically. So let's write down the original coordinates. So for A, it's originally at 0, -4. So that's where the original A is. For B, B is at -1, -1. And C is at -3, -3. Okay. And we're going to get an A prime. We're going to figure out what A prime, B prime, and C prime are. Okay. So let's go ahead and rotate our triangle. I'm going to erase what from the previous example. I'll keep my X and Y axis on here because done with that here. And then I will trace the pre-image. A prime, B prime, C prime. I'll put the tip of my pencil here, and I want to rotate, according to this problem, 90 degrees. It says 90 degrees. It's hard to see, but that's okay. Maybe I should have large print when I'm using this document cam. Okay. So we want to rotate 90 degrees. So I'm going to rotate. And when these line up again, the axes line up again, I know I'm in the right spot. So then now I can see, okay, that's where the image should end up, right? Notice I could see through my paper, and I could see that A prime should end up at 4, 0. Okay, I'm looking through and I'm looking at the grid below. Okay, B prime is at 1, 1, and C prime, or 1, -1, and C prime is at 1, 2, 3, -3. And there you go. This next one, it's very similar. But this time for question 5, the pre-image is kind of in the middle there. It's kind of a pain actually. But let's go ahead and write our coordinate points like we did for the other one. So A is currently at 1, -2. B is currently at 0, 1. And C is at -2, -1. We're going to get an A prime, a B prime, and a C prime. We want to know what are those coordinates for each of these image points. So notice it tells you over here what the degrees of rotation is going to be. It says it's rotated 270 degrees around the origin. Again, around the origin, that means 0, 0. So I'm going to put my crosshair over here, and I'm going to rotate 270. So I'm going to trace the pre-image, A, B, C. And I'm going to rotate 1, 2, 3 times. And I hope you're doing this at home too with all the rotation. I know it's a pain, but if you follow along, it'll make a lot more sense. Okay, so now we can see where these end up. So for A prime, it's at -2, -1. The new B is at 1, 0. And the new C prime, is going to be at -1, 2. Okay, just like that. Okay. I hope that sort of made sense. I'm going to put the document camera away, and let's go and let's look at section 1-4. So this is composition of isometries. So sometimes you want to do multiple things to a shape. So you might want to translate and then reflect, or you might want to reflect and then rotate, or maybe you want to do a rotation and another rotation, right? So these are all different things you can do to a pre-image to create an image. So this would be what we call a composition. So it's multiple transformations. And we call them, when we put them together, a composition of transformations. So a composition of isometries. Okay. So how does that work? Well, let's take a look at some simple examples. One of the main things I want you to see is when you do a reflection and another reflection across two parallel lines. So in this case, these two lines are parallel, and we're reflecting across those two lines. Well, you might notice that ABF and A prime prime B prime prime F prime prime they're kind of going the same way, right? So we can actually say, instead of a reflection across two parallel lines, that actually creates a translation of a certain distance. Now the distance is double whatever the distance between these two parallel lines are. So since these two parallel lines are 7 across, then we can say there's a translation to take triangle ABF to triangle A prime prime B prime prime F prime prime, and that translation would be a distance of 14. Okay, it's double whatever the distance between those parallel lines is. So in this one, number 2, we're actually going to do that first. If we are reflecting across these two parallel lines, then, and the distance between those parallel lines is 8.4, then it would be the distance between F and F prime prime would be double that. So that'd be 16.8. So the distance between F and F prime prime would be 16.8. Similarly, this one is a reflection and another reflection, but these lines are not parallel. So it's reflected, starting with ABC, it's reflected to here, to this triangle, and then reflected again to this triangle. So the triangle reflected across line M, and then it reflected again across line N. So in that case, what can we say? Well, we could say that that's the same as a rotation around point Q, and you double this. Okay, so it would be a rotation, that's lowercase r, of double whatever this is. So this is 54 degrees, so it'd be double that. So it'd be 108 degrees, comma, and then the center of rotation, which is Q. And then we say triangle ABC. So we do this rotation of 108 degrees around point Q on triangle ABC, and you get triangle A prime B prime C prime. Okay. So now let's work on questions 3 and 4 on page 27. So in this case, it's a composition transformation rule that describes the transformation from triangle ABC to triangle A prime B prime C prime. So first, let's go from triangle ABC to this triangle over here. So how would I go from this triangle, the starting one, to get to this triangle over here on the right? Well, you could see that it would probably just be a translation. It's just pushed over, right? So it would be a translation. Well, how much is it translating? Well, it's translating to the right. Let's look at A and look at its corresponding point. So that would be 1, 2, 3, 4, 5. So it's a translation, 5 to the right and 0 up and down. Then from there, so the composition, then from there we translate to this one. So we could look from A to this A prime over here. So how much down is that? 1, 2, 3, 4. So then it was translated 4 down. So how do I show a translation of 4 down? and 0 left and right. That'd be 0 and then down 4. Then we say triangle ABC. So we do those two things to triangle ABC, and we get triangle A prime, B prime, C prime. Let's try number 4. So number 4, we're starting with triangle ABC again, but this time we want to go to this triangle over here first. Okay, so how do we do that? Well, that would be a reflection, isn't it? It's a reflection across the y-axis. Hopefully you can see that that would be a reflection there. So for reflection, that's capital R, reflection across the y-axis. And then it's a reflection across this line here. So this line here is actually y equals -1. So notice it's a horizontal line going through -1 here. That's the reflection line to go from here to A prime, B prime, C prime, right? That's the reflection there. So then this would be another reflection, but this time across y equals -1. Again, we write triangle ABC, and that gives you triangle A prime, B prime, C prime. Okay, hope that makes some sense. Now we're on the last section here, section 1-5, and we could skip all this. I'll explain this as we go. Skip, 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 skip. And let's just go straight down to the practice problems. So let's go to page 32 and start the new practice problems. So here they're already giving you what happened here. So they took triangle ABC and they reflected across the y-axis and they reflected across the x-axis and they got this triangle DEF. Okay. So it says list all the pairs of angles and sides with equal measure. So we're writing congruent angles and congruent sides. So angle A here in the original, let's start by listing out all the congruent angles. So angle A will be congruent to angle D. Hopefully you can see that there. Now angle B, which one would be the congruent angle? Would that be E or F? Well, hopefully you can see that angle B, it would reflect down to here, then reflect over to here. So that would be angle B would be congruent to angle F, or sorry, E, not F, E. And lastly, must be angle C would be congruent to angle F. Okay, meaning that these angles have the same measure. Okay. Now, could you have done that without looking at the picture? Could you have just looked at this and been able to tell? Well, yes, because look, the A is in the same position as the D, right? So angle A will correspond with angle D. Angle A with angle D, see? B, angle B will correspond with angle E, B and E. Angle B with E. They're in the same position, right? A, then B, D, then E. A, then B, D, then E. Right? C last, F last. Okay, cool. So I don't even need this picture if I have this, right? You could also do the same thing with the side lengths, right? So AB So AB are the first two letters, right? AB. So that'll correspond to, without even looking at the picture, I know that that'll correspond to DE. Similarly, BC will correspond to what? What do you think? That would be congruent to EF, right? EF. And then the last side length, AC, will be congruent to DF. With that in mind, see if you can do number 2 on your own. Okay, last problem. Here it says write a congruence transformation that maps triangle ABC onto triangle A prime, B prime, C prime. So we're starting with triangle ABC, and we want to map it onto triangle A prime, B prime, C prime. So how would I go from this triangle to that triangle? Well, there's a couple different ways you could do it. But I think the simplest way is to first translate triangle ABC so that we make it where it ends up over here. Okay, so we want to move this triangle so that it ends up over here where I drew the blue one. So that would be a translation. And how is it translated? Well, if we look at the corresponding points, let's just look at point A. It would move 2 to the right and 1, 2, 3, 4, 5 up. So 2 to the right, 5 up. So that's the translation that moves this onto the blue here. Then we would want to reflect across the y-axis. So let's reflect across the y-axis. How do we show that? Capital R for reflect across the y-axis. Okay, and that'll get us back onto A prime, B prime, C prime. So then we put triangle ABC, and then that'll give us A prime. Whoop, I should probably put triangle here. Triangle A prime, B prime, C prime. And that's it. Okay, so this time maybe we had to do 2 different isometries to get to the image. Okay, well, I hope that all made sense. Hope you're able to get through all that. And if you need additional help, you could always email me. My email is ttrigg@ofy.org. And if you need tracing paper, you could ask me for tracing paper. It's also very helpful to have that tracing paper when doing rotations on the test and on the review. So having it on hand is very, very good. If I'm not around, you could always ask someone else in the center. I'm sure they'll be able to find some or at least order some for future. Okay, well, with that being said, I will see you guys next time. Have a great day.